So now let's come to these passages, and what I believe that both the passage was very scoring, and I would request everyone, when tomorrow I will tell you that how to attempt paper, I would suggest these are the two passages which you have to do first in subject. सबसे पहले आपको इन्हीं को पकड़ना है because they are advantages, but people don't realize that they are advantages. I will show you how they are advantages. Right, let's see that you can take full 20 marks in these passages by simple logic. Right, nothing has to be like should go wrong. तो ये वो पैसेज है जो सब्जेक्ट में आपको सबसे पहले करने होते हैं. Either they will be available from 141 to 150, or they will be available initially from 50 to 60, but generally they are available in last. So let's read the first passage for 141 to 145, and you will realize that they were very easy. So the first phototrophs, all of you are aware that the organisms which are responsible for doing photosynthesis are anoxygenic, means without oxygen, and likely use H2S as electron donor for CO2 fixation, generating elemental sulfur as a waste product. Right? So H2S as an electron donor and CO2 fixation we do. How could the first phototrophs have evolved at time when life existed mostly near hydrothermal system? Hydrothermal vent, all of you are aware. I have taught these things in structure of earth, that hydrothermal vent, black smokers, smoky pipes. This question was from there, and we have discovered in last few years a lot of biodiversity in hydrothermal vents where temperature is around 180 degrees Celsius. A clue came from the recent discovery of the anoxygenic phototrophs living in hydrothermal vents, and recently the photoautotrophs, which are anaerobic in nature, they have been discovered from hydrothermal vents in the complete darkness of the deep ocean, which is at the bottom and benthic region. These phototrophs actually carry out photosynthesis using IR radiation generated by the heat of hydrothermal vents. I told you temperature is at 180 and sulfite mineral comes out from there. Likewise, the first photosynthetic organism likely lived in the dark and at hydrothermal vents where H2S and infrared radiations were abundant. Diversification of anoxygenic phototrophs leads to species that were able to use a range of electron donors, including iron can also be used, which was abundant throughout the Earth's early oceans. Right, you know that. The ability to use the Fe2 plus as electron donor likely allowed early photoautotroph to escape from hydrothermal system to colonize the shallow region of Earth's early ocean, where light was abundant but were overlying water still provide the protection from UV radiations. The ability to use the solar radiation as an energy source allowed the phototrophs to diversify extensively. By 2.5 to 3.3 billion years ago, BYA, right, billion years ago, the cyanobacterial lineage evolved a photosystem capable of oxygenic photosynthesis in which H2O supplanted means replaced. Supplanted basically means replace H2S as a reductant for CO2. तो अब water आ गया था, right, in compared to H2S, thereby generating oxygen as a waste product. About a billion years later, eukaryotic oxygen phototrophs appeared and can be seen in the microfossil record. So this was the passage which you can quickly go through in exam, and I would request everyone, right, that you should attempt this question first because they are always easy. You should not be doing them in last. So now I will read the passage in front of you and I will show you that all the answers are available within this passage, right? So let's see the first question which is there, and how simple it is you will realize. The first question they are asking you that 141, the early photosynthesis organism likely existed in, right? So they said early photosynthetic organism likely existed in. So there is a line given in this question where you can easily, they said surface water, shallow regions of ocean, layers of ocean where visible light was abundant but UV light was absent, deep in the ocean at specific place in oceanic bottoms. So see this line here, you will feel comfortable, right? A clue came from the recent discovery of the anoxygenic phototrophs living in hydrothermal vent in the complete darkness of the deep ocean. So the line is matching here also, deep in the ocean, specific place in the bottom. So आपको दिख रहा है, वो actually में दिख रहा है कि यहाँ पे दिया हुआ है भाई hint, complete darkness of the deep ocean. So you can easily earn here 2 marks. So the correct answer for 141 is deep in the ocean at specific places in ocean bottom. Is that clear to each and everyone? Quickly guys, 5 minutes for this and 5 minutes for next, then we are done. Is this clear to each and everyone that how to decipher the information? Right. तो आपको घबराना नहीं है, ये क्वेश्चन सबसे पहले करने वाले क्वेश्चन है. यू शुड अटेम्प्ट देम फर्स्ट, बोथ ऑफ देम, because here is a chance to take 20 out of 20. Then let's go to the second question. Then they are saying the first photoautotrop. They are saying first photoautotrop use which of the following type of radiation for photosynthesis? This is also available into the passage, that what they were doing. It is written in the passage, right? It is clearly written in the passage here, right? It is clearly written in the passage. These photoautotrophs actually carry out photosynthesis using IR radiation. They were using IR radiations, right? It's very simple. They were using IR radiations. Are you getting my point? This line only, if you focus, you will understand. Using the IR radiation, right? So these are very easy question, and reading this passage is not a tough job. नहीं बन तो जाता, पर आपको जब पैसेज में मिला हुआ है तो why you are acting over smart? You should go by the passage ना. Sometime we do over smartness and make a mistake, right? That you are correct that IR ही होगा, but why we should be over smart? We should not lose a single question. So here the correct answer is IR, which is third option. Moving to question number 143. 143. They say identify the most probable time when the ability to use water for photosynthesis developed in the organism. So only one place they have given the line, and it is here, when they have become capable. So by 2.5 to 3.3 billion years, the cyanobacteria lineage evolved a photosystem capable of oxygenic photosynthesis in which water supplanted means replaced H2S as a reductant for CO2. So the timeline here given is 2.5 to 3.3. इसके बीच में, in between this the option comes. So definitely speaking, in between the options come, and the option is 3 billion. In between only 3 billion fitted. So the correct answer is 3 billion years ago. Is this clear to each and everyone? 143 is clear to each and everyone. Quickly guys, 10 more minutes. 143 is 3 billion years, right? I hope it is clear to each and everyone. Akansha, Ana, Karuna, Lata, Mittal, Pooja, Priya, Shiksha, Vedai. These are very simple questions, and I don't know why people do mistakes in them. These are free 20 marks. They can create a big difference, right? Here you don't need extraordinary knowledge of the subject, right? Then let's go to question number 144. It is also very simple, guys. In question number 144, that is also very simple. Why they are saying what they are saying? They said which of the following chemical species played a crucial role in the early phototrophs colonization in the shallow water of Earth's early ocean. So this line is also written there in the passage, and it is written here. You can study by yourself. Diversification of anoxygenic phototrophs lead to the species that were able to use a C range of electron donating Fe2+, which was abundant through Earth's early ocean. Right? सबसे पहले यही करना है, सबसे पहले यही करना है, इनको सबसे पहले करना है. devote 12 minutes, 15 minutes over each, because they are 20 marks capability. 20 marks is a big chunk. So the line indicate itself. You can see here, including Fe2 plus, which was abundant and throughout the early oceans. So iron or ferrous is the correct answer. Fe2 plus is the correct answer. Is this question clear to each and every one? 144. Quickly. That's why I'm saying everyone should go for this. 140, 141 to 150 should be the first target, these passages. ये मैं कल आपको बताऊंगा when I will take a 20-minute session that how to attempt the paper, right? How to attempt the paper. So Fe2 plus is the correct answer. Then first question, the last question 145 was even more easy. It was even more easy, right? Where we can see that they say the first 145, they say the first photosynthetic organism likely release. So it is also written in your passage that first photosynthese release what? So the first photoautotrophs were anoxygenic and likely to use H2S electron donor, CO2 fixation, generating elemental sulfur as a waste product. So they used to release elemental sulfur. Now tell me what was difficult in this passage? Nothing. Nothing was difficult in this passage. So elemental sulfur is the correct answer. Is this clear to each and everyone? Quickly. Is this clear? Now I will show you a magic in between also, that the notes which I teach last time, and I was teaching this from last 3 years, and I was confident that one day the teacher will definitely give a big question from this, and my bet was on this chit or this handout which I used to teach every year, and this year also I have taught this handout. Let me show you. And directly they took the second passage from the same handout, and I was also surprised when I looked at it, that is it so. So you see this handout which I teach every year, and from last I guess couple of year I was teaching, right? बहुत सारे सालों से, मतलब 5-6 साल से मैं ये पढ़ा रहा हूँ, ये हैंडआउट जो है ओशन वेव एनर्जी, राइट? सो दिस ओशन वेव एनर्जी आई वाज टीचिंग फ्रॉम 4-5 ईयर, राइट? बहुत सारे लास्ट टाइम से मैं पढ़ा रहा हूँ, ठीक है ना? अब देखो तो सही। नहीं, बनाना कुछ मुश्किल नहीं है, अगर आप रीड करेंगे तो बन जाएगा, ऐसा कुछ नहीं है, ये मुश्किल वाला नहीं होता। अब वो सबको करना है। एंड देन आई टॉट यू दीज फार्मूलाज। I yesterday, day before yesterday also I taught you these formulas, that we calculate the energy or the total potential and kinetic energy as this half rho Ag square, where L is the length, wavelength, right? And A is the amplitude, right? And amplitude in meter, and density is the density. Then I also told you that Vg, which is L upon 2t, right? The wave propagation speed, and this average energy flux or power of the wave period, right? It is half rho a square g L by 2t. And then in the last I told you, I will show you a surprise, and L is equal to gt square upon 2 pi, and rest of the formula. Then I also teach always you this formula, which is J is equal to 0.5 h square t, and there is written a line also. And then I will read the passage, you will laugh that what they have done. They have just copied and framed over this handout, if you see. So see here, in deep water, the wave power spatial flux of wave front crust is given by wave height hs and the peak wave time period s. Based on these two parameters, the incident wave power in joules per kilowatt of wave front crust associated with the each sea state record is 0.42 h square tp. And keep this line with you. It should be noted that wave power varies with the square of the wave height, right? Means wave power is directly proportional to the square of the wave height, which is given here. In other words, if the height of the wave is doubled, then the power generated is 4 times. Now I am closing this PDF. And now you will laugh after looking into like what they have done, what kind of blunder they did. I don't know whether it was a fate or whether it was our prediction, but we have been teaching this from last 5 6 years, this handout. Now let's start reading the passage. I will also read with you people, and you will see that exactly what they pick was our prediction. So you can see here for 144 to 146 to 150. Wave expend their energy when they reach the coastline, but the amount is surprisingly large. For example, the energy expended on a 40-kilometer length, they are talking about the wavelength of open coastline by the waves with a height of about 1 meter, wave height is 1 meter, over a period of time is approximately equivalent to the energy produced by one average size nuclear power plant, right? They have done a comparison over the same time period. Time period is same. Wave energy is proportional, approximately proportional to the square of the wave height. Same line they copied. What was in our handout? Same line they copied. Thus, if wave height increase 5 to 5 meter, which is typically for large storm, then the energy expended or wave power is 25 times over that of the wave height of 1 meter. Means if you increase the wave height, which is definitely because wave power was directly proportional to h square. So if you make the 5h, then it will automatically become 25 times the power. When the wave enter the coastal zone and shallow water, they impinging of bottom and become steeper. Wave steepens in the ratio with the wave height to the wavelength. Wave are unstable when the wave height is greater than the 10% of the wavelength. Here there is a message which is hidden, that when you say that wave is unstable when your h is greater than zero point 0.1 times of lambda or L, right? Whether you say lambda or whether you say L is the same, wavelength we denote by this, right? Message is this from here. Then in the last, as wave move into the shallow wave, the wave period remain the constant. Wave period will not change, but the wavelength and velocity decrease and the wave height increase. The wave changes shapes from the round crest and trough into the deep water to peak crest with relatively flat trough in the shallow water close to the shore. Perhaps the most dramatic feature of the wave entering the shallow water is their rapid increase in height. The height of the wave shallow water, but they break and maybe such as twice their deep water height. So now the things are very simple, but I don't know why people did mistake in this question and they were into an expression कि ये तो पैसेज से था ही नहीं. सब कुछ पैसेज से था. देखो अभी आपके सामने मैं दिखाऊंगा that सब कुछ पैसेज से था, and with the help of passage we could have dismantled this question also very easily, to be very frank, right? So in the very first question, which is basically 146, they have asked what? They ask you which of the following is a characteristics of the shallow water close to shore. So which are the characteristics of shallow water close to the shore? तो यहाँ पे आपको दिखेगा the wave changes shape from the rounded crest and the trough in deep water and peak crest with relatively flat trough in the shallow water close to the shore. Same line, shallow water close to the shore. So the feature is the flat troughs. Trough, all of you are aware what is trough. When I was teaching this PDF in the energy, I told you this is my trough. This is my trough. This is my crest. Right? I told you what is crest and trough. So the trough. So flat trough is the correct answer for this question. As you can see here in the passage, they have mentioned about the flat trough. बहुत easy है guys, identify करना कुछ भी tough नहीं है. So you can see here that flat troughs in the shallow water close to shore. So shallow water close to the shore. Flat trough is the characteristics. So the correct answer is third. Is that clear to each and everyone? Quickly. जल्दी से बताएंगे. Quickly. Is it clear to each and everyone? Anyone having any doubt? 5 more minutes. 5 more minutes and this is dismantled. Right? So is it clear to each and everyone? Yeah. So this was there. Now let's move to the question number 147. बहुत सिंपल क्वेश्चन थे गाइस, थोड़ा सा अंडर एस्टिमेट कर गए एग्जाम को. Now you can see here that in the next question 147, what they have asked that when wave move into shallow water, which of the following would not change? Simple. Wave period will not change when it move to the shallow water. It has been mentioned. It has been mentioned, like you can see here. You can see here, as waves moves into shallow water, the wave period remains constant, but wavelength and velocity decrease and wave height increase. This was the line. So you can see here that wave period is the quantity which do not change, that remains constant. So my answer will be the wave period, because that remains constant. So wave period is the correct answer. Is it clear? 147 to everyone. Quickly. 147 to everyone. Clear? Next question is very easy. Next question is very easy. And hint is given in the passage itself. You need not to do the lot of magic. As you can see here, right? Wave energy is approximately proportional to the square of the wave height. Thus, if the wave height is 5 meter, then which is typical for a large storm, then the energy expended or wave power is 25 times over the wave that of the height of the 1 meter. Either you could have done with this hint, right? Or you can just simply apply the formula that what was the wave power? Wave energy was having proportionality to h square, right? So E1 is equal to h1 square, E2 is equal to h2 square. Divide both of them, E1 upon E2. H1 is H1, the below one is 3H1, and square of them, it will become E1 upon E2 is equal to 1 upon 9. So E2 is equal to 9 times of E1. So correct answer is 9 times. Otherwise, I could have done, if the 5 meter is having 25 times energy, then 3 meter would have 9 times energy, because energy is proportional to h square. It was very simple. The formula is there. Is that clear why it is 9 times square of height? Next question was tricky and people were not able to identify this. This was the question which exactly need the help of my handout. Without that, it was very difficult to do. So there was a data given in this passage which says that initially, which says that, for example, the energy expended on 40 kilometer length, when the wavelength is 40 kilometer, by the waves with a height of about 1 meter over a given period is approximately equivalent to energy produced by one average sized nuclear power plant. So we have been given height 1 meter and the wavelength as 400 kilometers. This was one of the hint. This was the initial data, and they want the answer in comparison to this data. So guys, I show you the formula, and I wrote the formula in my lecture also, that power for these wave power, we write the formula that energy into velocity of wave propagation, energy is half rho g a square into Vg is basically L upon 2t. Amplitude is also h by 2, because here we have been given wave height. When you will put the amplitude, half rho g h square upon 4 into L upon 2t. So this is the wave power. But my job is to see that what is the relationship between the wavelength and the wave power. So wave power is proportional to h square and proportional to L also. So the formula which you should have used in here is that power is proportional to h square L. Means if I write one equation, power 1 is equal to h1 square into L1. This is my equation 1. Is this clear to each and everyone? Quickly. Then you will see the magic. That power is proportional to h square, power is proportional to L. So I can write a equation that power is equal to h square L1 for first one, right? तो यही इस पूरे को भी लिखेंगे चलेगा, but I want to do it cut short. Everything else will cancel, right? So I could have simply written here that power 1 is equal to h1 square L1. This is equation 1, where I will put the value power 1. And what was the height there? What was the height there for the value which is given in the passage? The height was 1 meter, 1 square, and the wavelength was 400 kilometer. This was equation first. Then the second equation for this data I have to make. Power 2 should be equal to h2 square into L2. So power 2 will come how much? Height is 2 meter, 2 square into L2 is how much? 1000. So it will become 4000. Now you divide both of them. So what you will get? I will get P1 divided by P2 is equal to, in first what we are getting? 400. In second what we are getting? 4000. 400 divided by 4000, and automatically this will come 1 by 10. And from here we can say that P1 upon P2 is equal to 1 by 10. So P2 will be 10 times of P1. This was the question of the paper. ये सबसे बढ़िया क्वेश्चन था इस पेपर का, पूरे पेपर का. इसको आप तुक्के में गैस नहीं कर सकते थे, ठीक है? ये तुक्के से गैस नहीं होता था, ये तुक्का लगाने की चीज नहीं थी, ये इस फार्मूले से ही होना था. आई थॉट ओवर इट फॉर अ लॉन्गर पीरियड ऑफ टाइम, and then I think this was the question of the exam which was actually testing the brain of the student, right? No other hint was available which give you the answer 10 times. So 149 is 10 times. Is that clear to each and everyone? तो कौन कहता है prediction नहीं होती है? We say the prediction happens, and that handout have proven it. For continuously for 6 years I taught that handout, and ultimately it lead a passage, right? No other logic will fit here, because if you do h square then it become 4 times, you will do a mistake. If you do h square then it become 4 times, you will do a mistake, right? And there the value is 400. If you do from that time, then it will give 2.5 times. Both the answer are incorrect. So this was the trick for the question. The next question is also very easy. Let me tell you, very easy question. Next question. In the passage, they said when you have the height, yeah, unstability. Unstability they have mentioned in the passage that, yeah. So wave are unstable when the wave height is greater than 10% of the wavelength. Simple. Means when you will say that wave is unstable, there is a criteria. It says that h should be greater than, wave height is greater than 0.1 times of wavelength, which is L or lambda, whatever you say. Then we say it is unstable. Now let's check it. Simple. If you keep checking it, in the very first option you say that wave height is 2, wavelength is 30. What will be the 10% of 30? That is 0.1 of 30. So 0.1 will be 3. So now you know 2 is greater than 3. No, 2 can never be greater than 3. So this option is wrong, because when you calculate the 0.1 lambda will be how much? 0.3 na. So is it okay that 2 meter, right? That wave height is greater than 0.1 times of this? That is wrong. 2 cannot be greater than 3. This is incorrect. Next, wave height is 2.5 meters, and L, 0.1 times of L will be what? 2. This is correct. Here the wave is unstable. In the next option, wave height is 3 meter and 0.1 times of this is what? 4. Can 3 be greater than 4? No, incorrect. Fourth, wave height is 1.5. What is the wavelength? 10%, 2.5. Can 1.5 be greater than 2.5? Incorrect. So only in the second choice we are getting that condition fulfilled, that h is greater than 0.1 times of wavelength. Then the wave is unstable. So second is the correct answer. So finally that topic, ocean wave energy paid, right? Which I was teaching from lot of year. This time also I taught because of the same faith that it will get you some question. So the correct answer here is 2. Anyone having any doubt? This is what you called learning the things with logic. खाली ABCD से कुछ नहीं होता है वर्ल्ड में. Let me tell you very clearly. ABCD will never give you the quality things in life. You should know the logic. तो लॉजिक को ढूंढना है आपको लाइफ में ना. दैट इज द अल्टीमेट थिंग. इफ यू गेट द लॉजिक देन इट इज करेक्ट. एंड नाउ यू कैन सी व्हाई वी से कि हमारे हैंडआउट से है, हमारे मटेरियल से है, हमारे सेलेक्टेड सोल्यूशन से. हम क्यों कहते हैं व्हाई वी से दैट इट इज फ्रॉम आवर सेलेक्टेड सोल्यूशन, आवर हैंडआउट, आवर मटेरियल. आई हैव शोन यू द प्रूफ that handout I am teaching from last 7 years, but ultimately they picked the same line in the passage. So with experience we can say these are the things which will give you the maximum benefit. So with this I will stop here. We will have a brief 15 to 20-minute class tomorrow, most probably in the 7 p.m. slot only, that how to attempt the paper. I do that every semester. So I just take your 20 minutes tomorrow. Till then you enjoy this. We are done with the paper. We are done with the full syllabus. We are done with everything. All the things have been done in detail. All the team members have worked very hard day and night. Teaching 10 hours a day is not a cakewalk, especially in the online stuff. So our team have worked very hard and I'm proud of them for same, and hopefully we will see the good outcome from the student. With this I will stop here. All the 150 questions we have discussed, right? And hopefully they will be available soon in your cloud also, right? So we will see you guys tomorrow for a short section for like how to do the paper, and rest of the things are there. It is already available into the cloud, right? It is already available into the cloud by the name of paper 2 205 discussion by Dr. Gaurav Sharma. Already 8 part are there. 9th and 10th part will be uploaded soon, right? Today it will come. Today itself it will come, not tomorrow. Don't worry. It will come today itself. So see you guys tomorrow for a short class. Till then you enjoy and study. Take a peaceful sleep. No need to hurry and worry. You have studied the best out of the rest, right? Nobody has studied in that much of depth. Nobody has such kind of resources. So you can beat anyone on 25th. So stay alert, right? We will see you for a short class for 20 minutes tomorrow. Take care. Good night.